Hello and welcome to Talk Tech. I'm Kristen White and joining me today is Bryan Pate, founder of PT MotionWorks, a company that makes a novel product called the elliptiGO, which is basically a hybrid of an elliptical trainer and a conventional bicycle. So Bryan, tell me a little more about the product.
Well, the product came as a concept about 2.5 years ago. I was a former Ironman triathlete and former Marine and football player and a lot of things that are abusive on the lower extremities.
Sure, of course.
And found that I couldn't run anymore. And so I started to go and use the indoor elliptical trainer and really liked it, really liked the motion, liked the workout, but hated being in a gym. So I thought to myself, I'll go buy an elliptical trainer that I can ride on the street and then I'll have my problem solved.
Sure.
And there wasn't one.
Nothing.
And so I got in touch with a friend of mine, Brent Teal, who's also a co-founder of PT MotionWorks and the designer of the elliptiGO, and got in touch with Brent and sketched out on a newspaper actually what I was visualizing as a potential cross between a bicycle and an elliptical trainer, and he said he could build one.
Okay.
So we entered into a partnership, and a couple of years later we have an elliptiGO.
So can you summarize the key features of the cycle?
Sure, absolutely. So the bike is powered by an elliptical motion, and I'm going to run it in backwards so you can sort of get a sense of it. And that enables an upright position for the rider. It's a weight-bearing exercise, so you get a better musculoskeletal benefits, and you also work out more of the muscles that you use in running.
Sure.
You also don't have a seat, so you don't have any associated seat pain that people find with discomfort with bikes.
Right.
And then also you're standing upright, and so you don't have the same hunched over position as a bicycle does.
Right.
But we do have, similar to bicycles, we have 8 gears, and they're actually located in the hub, so there's no derailleur. And then we've got pedal platforms for your feet, and the mechanism's actually what's called a slider crank mechanism, and that's what creates the elliptical motion. It feels a lot safer to ride in traffic.
Oh, really?
Because you're so high.
Oh,
so when I'm on this, I actually can see over Suburbans.
So because you're so high and because you're standing, is it difficult to balance at all?
It's not. We were really worried about that. We were worried about balance, maneuverability, and just whether or not it would even, if you could just function, and if whether or not like pedaling in this way would, canter the bike back and forth. And what we found was that it's exceptionally stable. There's a couple reasons we think. Number one, it has a long wheelbase, and it turns out that stability for a two-wheel vehicle like this is not a direct correlation to wheelbase, but wheelbase is one of the largest influencers of how stable something is. The other thing we found was that the standing position actually is what, at least from our experience, we would do normally when we were on a bike and we were coming across kind of undulating terrain or kind of getting into an unstable situation.
Sure.
I would actually get off the seat
and
stable myself with my legs and my knees.
So are there any patent or IP issues with the elliptical design?
Our philosophy of approaching this was, let's make sure we can lock down the intellectual property first, because if it ever catches on, it becomes a commodity business. And cycling's more of a commodity business now. You can buy a bike for $100.
Right, if it becomes in the public domain.
Well, if we can't lock down the IP, we're going to get outcompeted by people who are more efficient than two guys who don't build bikes for a living, right?
Yeah.
So we had actually already filed our own patent at that time, focused on some of the key components that we believe are required for a successful system, things like retention. So the fact that this wheel has a V-groove down the middle of it and rides along this beam, and so therefore is captured laterally and then captured underneath by another bearing that runs on the bottom surface of a rail that's attached onto the frame. The adjustable and extended crank arms in the back allow for the travel. So the distance and the distance that your foot can travel in terms of stride length is determined by the distance or by the length of this pivot axis to the center of the crank arms.
So it's adjustable.
It's adjustable and it's custom.
So as you mentioned, you don't use a standard derailleur.
That's correct.
So can you describe this mechanism?
Sure.
And why you decided to go with that?
So we decided, I spent a lot of time cycling, and I ruined a lot of clothes. Taking off my rear wheel, fixing a flat. I can't tell you the number of pairs of shorts or jeans that I have a half circle of grease you know, in the perfect shape of a
Sure.
front crank. And a lot of that it has to do with kind of how the derailleur interacts with the gearing. There are 4 companies that make good internal good gearing systems. Are called planetary gear systems, and they actually allow you to select multiple speeds within the hub.
Okay.
So really simply, there's sets of gears. There's 8 what are called planet gears, and then 1 sun gear.
Okay.
And then you move the sun gear back and forth to engage whichever planet gear you want
Okay.
to.
So the 2 of you together, do you build this yourself, or did you?
Yes. So Brent actually built this in his garage.
Okay. What did that process look like, sort of step by
It
step,
was
out of curiosity?
crazy. So this is actually the second one we built. The first one we built had a single mono frame and was a real, just kind of proof of concept.
Sure.
So it was really adjustable. You could adjust the guide track angle, where the pedals were. In fact, the pedals were huge, and you could just put your foot wherever you wanted.
Right.
And then you could adjust the rear. Everything was adjustable. And what we were trying to do was A, prove that these things could be ridden.
Sure.
And then B, figure out what kind of angles for what setup would be optimal. We had Alpha, which was our first, and then we were going to build Beta.
Okay.
But we decided to skip Beta and we went to This is Charlie.
Oh,
so
Charlie.
this had been nicknamed Charlie until we actually named it the elliptiGO. And we found that the real critical factor was getting the stiffness and bending, and that took a lot of design work to actually figure out how to make that happen. And so a lot of finite element analysis. And then once we decided to go ahead and start cutting steel, we bought a mill, we bought a bender, a tube bender, and we put together a little shop in half of a 2-car garage.
Okay.
And that he rents.
A
his
garage
half.
operation.
It's a
literally.
total garage operation. And we started experimenting. So the first thing he did was he built one of these out of conduit, just really thin, cheap tubing. The tubes are extremely thin.
Right.
And so there's a lot of concern with kinking them as you're bending.
Sure.
What he did was he packed them with sand.
Oh.
After doing a ton of experimentation, he figured out that sand is a really interesting medium, if you will, and it can act like a fluid sometimes and act like a solid sometimes.
So it kept it from kinking.
It kept it from kinking.
Okay.
And he did it on just an old hand bender.
So do you currently have any investors? Or are you bootstrapping your efforts at this point?
We got 1 investor, and that's me.
Oh.
Well, I guess we have 2, myself and my wife.
Okay, right.
And she's not that willing of an investor.
Thanks for speaking with me today.
Oh, great. I
This
enjoyed
was
it.
fun. And thanks for watching Talk Tech.